One of the most important features of RhinoArtisan is that it is fully parametric. To better understand this concept, we'll start by creating a round gemstone of 1/2 carat. We'll add a basket setting to it. Each command in RhinoArtisan includes its own editable library of models. We can modify any of them and customize the design to our preference. There are countless parameters available to adjust. Once the basket is created, we can edit the shape of the gemstone, and it automatically adapts to the new form. But it doesn't stop there. Let's switch back to a round shape and also increase its size. The basket instantly adjusts to both the new shape and dimensions. Now let's look at a more complex example, a cluster setting. Before editing it, we'll also create a cathedral shank to complete our model. To do this, we go to the Shanks tab and click on the Cathedral command. With the full ring assembled, we can continue editing it as we like. We'll change the center stone to an oval shape, and the cluster automatically adjusts to match the new form. The shank is also editable. We can modify its parameters directly in the command panel or by using the gumballs, seeing all changes in real time. Once the design is ready, we can adjust the ring size, for example, changing it to a US size 10. The entire model automatically adapts to the new size. Another useful option is the ability to switch to manufacturing mode. This mode prepares the model for production by extending the prongs for the jeweler. At any moment, we can switch back to rendering mode and continue editing the model. The automatic Pavé command allows us to position gemstones automatically across a surface. In this example, we'll use this pendant, and the first step is to create a few reference stones. Once that's done, we activate the automatic Pavé command. We add the surface, then select and add the reference gemstones. As we can see, they are now included in the command. Next, we can select the gemstones and set them as locked stones. They'll turn gray, indicating that their positions won't change during the computation. In the panel, we can add different gemstone sizes. These sizes define the gemstones that the command will use during placement. It will start with the largest stones and gradually fill the remaining space with smaller ones. Since we want a symmetrical layout, we enable the symmetry option. Now, we simply click Generate Automatic Pavé. The command begins to calculate and distribute the stone symmetrically across the surface. At any point, we can make adjustments. For example, select a stone and increase its size or move it. If a stone turns red, it means it's intersecting with others. But by clicking Recompute, the system automatically adjusts their positions. We can also remove any gemstones that we don't need. Once the layout looks correct, we move to the Prongs tab. Here, we define the prong parameters and click Create Automatic Prongs. The program calculates and adds all the prongs automatically. As with the gemstones, we can also add or remove prongs manually and adjust their sizes as needed. Next, we go to the Cutters tab, select the preferred cutter type, and click Show to generate it. When everything is ready, we confirm the command. Finally, we perform a Boolean difference, and our model is complete. The Breakdown Details panel, located under the Files tab, allows the user to view all cost-related data of the current model, including the metal and gemstone prices, process costs, and other detailed parameters. To generate this breakdown, we first go to the Manufacturing tab and open Breakdown Settings. Here, we fill in all the necessary fields, such as general information, market prices, and other production data. The provided link gives access to the latest metal prices from the LBMA market, ensuring accurate, up-to-date cost references. Next, we enter details related to gemstones, printing, casting, finishing and polishing, additional processes, stone settings, and timing. Once all the information has been filled in, we return to the Files tab and click on the Breakdown Details panel. We press Create, and RhinoArtisan automatically generates all pricing data and the total cost of the piece based on the information entered in Breakdown Settings. This includes the total price, the cost of metals and gemstones, and all processes that have been added. We can then open the Report panel to enter additional information related to the model or client. Using the More button, we can add extra fields if needed. After that, we can choose from the preset templates provided by RhinoArtisan, or create our own custom templates, and simply click Create. RhinoArtisan then generates a complete report with all model information. As mentioned, each template is fully editable, allowing you to adapt it to the needs of each client. In this example, we'll look at the Quick Check command, which allows us to detect meshes that are not ready for 3D printing. Here, we can see that this model has an open mesh, so let's run Quick Check. We select the object, and the system automatically highlights it in red if the mesh is not correct, or green if it's printable. To fix the issue, we use the Automatic Repair STL command. We select the command and set a precision value of 0.01. We enable the option to fill holes, and if needed, we can also use custom settings. In this case, we'll keep all values at 0 for greater accuracy. Next, we select the meshes that are not correct and apply the command. As we can see, the system has now filled the gaps in the mesh. In the report, we can verify the repair results. We confirm, and now that the STL mesh is repaired, we run Quick Check again. This time, the model appears in green, indicating that it's ready for printing. In the Manufacturing tab, we can find a wide range of tools designed for the production process. In this example, we'll take a look at the Sprue Inner Branches command. First, we'll switch from rendering mode to manufacturing mode. As we can see, when switching modes, the prongs extend, adapting the model for production. After that, we can add sprues to our model. Since we're working with an eternity ring, we'll use inner sprue branches. We activate the command. We can hide the gemstones to make the process easier, and start by adding our model to the selector. We can then adjust the parameters, for example, setting the central sphere to 2 mm and the contact area to 1 mm. Before adding the branches, we'll enable 4-way symmetry to make the process faster. Next, we click Add Branches, select the areas of the model where we want to place them, and just click. We can use the gumball to fine-tune the positioning for more precision. We repeat the same process on the lower part, again adjusting the position with the gumball until everything is aligned. Once the sprues are in place, we confirm the command. The model is now fully prepared and ready for casting. For this model, we'll use the inner tree sprue. We activate the command and add our model to the panel. The base of the sprue appears automatically. We can adjust its size either using the gumballs or by entering exact values in the panel. For example, in this case, we'll set the bottom diameter to 1.75 mm and the top diameter to 1.54 mm. We can also change the height using the gumballs. Next, we enable symmetry, since we want to add 4 branches. Before doing so, we'll set the contact diameter to 1 mm. Then, we simply click on the points where we want to place the branches, and our sprues are perfectly positioned. Once ready, we confirm the command, and the sprues are created. Now, let's look at another command, Multiple Copy Sprue, which is used when we need to create sprues for several objects at once. We activate the command, and the first step is to select all the objects. Next, we click on the Trunk selector, which allows us to define 2 points, the starting point and the ending point, for creating the trunk. As before, we can adjust its parameters. In this example, we'll set the top diameter to 2 mm and the bottom diameter to 2.3 mm. Now we'll add the branches. For the first diameter, the one connecting to each basket, we'll set 2.10 mm, and for the second diameter, 1.40 mm. We click Add Point, select the position where we want the branch to start, then select a point on the trunk. The connection is created automatically. We repeat this process for the remaining baskets until all are connected. Once everything is in place, we confirm the command, and our sprues are now complete. The Ring Resizer tool allows us to adjust the size of a ring while keeping all proportions and design elements perfectly intact. To begin, we go to the Manufacturing tab and open the Ring Resizer command. We start by selecting the shank and adding it to the selector inside the command panel. Since in this case we don't want to deform the stone setting area, we'll switch the mode to variable. This activates the gumballs, allowing us to define the area of the ring that should remain unaffected. For this model, we'll open the angle to about halfway across the shank, ensuring that the setting area remains protected. Next, we select the ring sizes we want to generate. In this example, sizes 51, 59, and 65. We'll then open the Identifier tab and activate it. Here, we can add a reference identifier. In this case, we'll use RA followed by the size. Now, we'll set the parameters for the sprue. We'll change the height to 4 mm and the inside ring to 0.5 mm. Next, we'll set both the top X and top Y to 1.5 mm and activate them. Once all parameters are ready, we click Refresh to compute the scaling. Multiple copies are created automatically in the selected sizes. Each one is labeled with its identifier, including the ring size and its corresponding sprue. After confirming that everything is correct, we can accept the command to finalize the resized rings. As we can see, even though the rings have different sizes, the settings remain perfectly aligned, maintaining the same proportions and spacing as in the original design.